Hey everyone, I hope you're doing well today. In this video, let's talk about how to solve one-step equations. And while you can totally solve one-step equations that have fractions and decimals in it, the problems in this video won't have either of them. To show you how to solve one-step equations, it's important to know the identity properties. The first identity property we'll talk about is called the identity property of addition. Basically, if you take any number or any variable, something like x maybe, and you add on 0, you get the same thing that you started with, which is going to be x. Long story short, 0 is the only number in the world you can add on to something else and it doesn't change the value. Besides the identity property of addition, there's also the identity property of multiplication. While 0 is the only number you can add and still get the same value you started with, can you think of the only number you can multiply by so you get the same value you started with? If you were thinking of 1, you were absolutely right. It turns out if you multiply 1 by any value, or 1 times x, this is also just going to equal x. Multiplying any value by 1 will result with the same value we started with. Throughout this video, you're going to notice over and over again that this 0 or this constant is going to always disappear. Similarly, this 1 or this coefficient is also going to disappear. When solving equations, you really have two big goals. The first one is going to be always to get 0, and the second big goal you want to have is always to get 1. If you can get the constant term to be 0 or the coefficient of the variable to be 1, you can then solve equations. When solving equations, not only do we want to understand the identity properties, but we also want to understand the properties of equality. Basically, there are 4 properties of equality that we'll use to solve these one-step equations. The first one you want to know is called the addition property of equality, and that just means that you can add any value, whether it's a number or a variable, to both sides of the equation as long as they're the same. The second property of equality you'll see is called the subtraction property of equality. Just like the addition property of equality, we can subtract any number or variables from both sides of an equation. Then there's the multiplication property of equality. And just as you may have already suspected, this just means you can multiply both sides of an equation by the same variables or the same numbers. And the final property of equality we'll use in this video is called the division property of equality. When given an equation, we can divide both sides of the equation by the same number or the same variables. Now that we've gone over all the important properties to solve one-step equations, let's get into some practice problems together. I encourage you to grab some paper, something to write with, and let's do some math together. For example 1, let's solve the equation x plus 7 is equal to 10. As we're solving this equation, don't forget we have two main goals. First, we want to get our constant to equal 0, and then we want to get our coefficient to equal 1. When we see this plus sign on the left side of the equation, we're going to want to use the opposite operation or subtraction and subtract 7 from both sides of this equation. By subtracting 7 from both sides of the equation, we're using the subtraction property of equality. It's important to know that we subtracted 7 from both sides of the equation so we could get 0 on the left side for our constant. On the right side of the equation, when we subtract 7 from 10, we get 3. At this point, we've reached our first goal, as we were able to get 0. Remember, the identity property of addition states that we don't need to write plus 0 because adding 0 gets the same value, so we can just write x is equal to 3. And technically, even though we didn't have to do any work for it, we reached our goal of getting 1. The reason why we have a 1 is because we have an invisible 1 that's being multiplied in front of this x, or it has a coefficient of 1. Remember, multiplying any value by 1 stays the same, so that's the identity property of multiplication. While it's not necessary to write that for this problem, it is important to know that we do have a coefficient of 1. In the end, we can really say that x does equal 3. Let me show you how to check your solution now. To verify that x does equal 3, let's substitute this back into the original equation to see if this actually is true. So substituting in, we should say that 3 added onto 7 is going to hopefully be equal to this 10 that we have on the right side. Since 3 plus 7 does equal 10, and we can say that 10 does equal 10, we know that we found the correct solution. In example 2, let's try solving the equation x minus 5 is equal to 3. While in example 1 we had an addition sign, notice how in example 2 we have a subtraction sign. To reach our goal of getting 0, we're going to have to add 5 to both sides of this equation. Remember, we're allowed to add 5 to both sides of this equation because of the addition property of equality. It's a good thing we decided to add 5 to both sides of the equation because when we add this plus 5 to this minus 5 on the left side of the equation, we get x plus 0. And on the right side, nothing really special is happening, we just have to add 3 plus 5 and that's equal to 8. By using the addition property of equality and adding 5 to both sides of the equation, we were able to get 0. Because adding 0 doesn't ever change the value of anything, we can drop the 0 just to write that x is equal to 8. Don't forget that there's technically an invisible 1 that's being multiplied by this x. And the reason why we don't need to write the 1 is because of the identity property of multiplication, where anything times 1 just stays the same, so we don't need to write it. Well, in this equation, we didn't need to do any work to get the 1. In other equations, we will. Therefore, we can conclude that the solution to this equation is x is equal to 8. And let me show you how to check this real quick. To check to see if x does equal 8, let's take this 8 over here and substitute it in for this x and see if this equation does make any sense. So we should write x minus 5, and we're going to see if this does equal the 3 that we had on the right side of the equation. So what is 8 minus 5? Well, 8 minus 5, I believe that's equal to 3, and so since 3 does equal 3, we know this equation does make sense and 8 is the solution. In example 3, let's try solving the equation 6x is equal to 54. While in the first two examples we had addition and subtraction, notice how this example only has multiplication. Don't worry about having to get 0 because we already have it from this equation. Technically, we could write this equation as 6x plus 0 is equal to 54. Because writing plus 0 doesn't change the value of anything, let's just get rid of it. So back to where we started, we technically have this equation 6x is equal to 54. Remember, 6x really means 6 times x, so we know that 6 times some number is equal to 54. So in example 1, when we had addition, we had to use subtraction. In example 2, when we had subtraction, we had to use addition. So in example 3, because we have multiplication, let's use division. We're going to divide both sides by 6. And in case you forgot, writing the fraction bar over 6 really just means that we're dividing both sides by 6. It's just another way of writing division. By dividing both sides by 6, we're using the division property of equality. On the left side of the equation, we have 6 times some number x, but then divided by 6, so these 6's are going to cancel out with each other, and we're left with 1 times x on the left side. On the right side of the equation, 54 divided by 6, or 54 over 6, simplifies down to equaling 9. We've reached our second goal of getting 1. Our coefficient for x is now equal to 1. By the identity property of multiplication, we don't really need to write this 1, and we can just write that x is equal to 9. There's our solution. Let's just do a little quick check to make sure this answer does make sense. So we got that x does equal 9, and let's substitute that in for x in the original equation to see that this makes sense. So remember, this is 6 times x, and we think that x is equal to 9. So we're going to say 6 times this 9. And we're going to see, does that actually equal the 54 that we had on the other side? Well, if you think about it, and 6 times 9 does equal 54, if you're sure that makes sense, and 54 does equal 54, then we are good to go. We know this is the solution. X does equal 9. Here's example 4. Let's solve the equation x over 4, or x divided by 4, is equal to 12. Just so you're seeing the different types of the equations, in example 1 we had addition as our operation, in example 2 we had subtraction, in example 3 we had multiplication, so this is example 4 where we have division in the equation. To show you why we don't need to get 0, remember that we could technically write this equation as x over 4 or x divided by 4 plus 0 is equal to 12. In this particular equation, we already know that the constant is equal to 0 on the left side of the equation. Don't feel like you ever have to write those steps out when you're solving your equations. I'm just doing so in this video to show you what's going on. In this particular equation, our operation is division, and we're going to solve it by multiplying both sides by 4. Remember, multiplication is the inverse operation of division. By multiplying both sides by 4, we're using the multiplication property of equality. The reason why we're multiplying both sides of the equation by 4 is because when we have x over 4, which is x divided by 4, and then we multiply it by 4, these 4's are essentially just going to cross cancel and become 1's. Then on the left side of the equation, we just have 1 times x, and on the right side we have 12 times 4, and 12 times 4 is going to equal 48. Notice that by using the multiplication property of equality and multiplying both sides of the equation by 4, we were able to get 1. Since 1 times any value of x is just going to equal x, we can use the identity property of multiplication and just write that x equals 48. There's our solution. And here's one final check. We think that x does equal 48, so we should be able to take the solution of 48 and substitute it in for this x that we have in the original equation. If x does equal 48, then we should be able to say that 48 over 4 does in fact equal the 12 that's on the other side of the equal sign. 48 divided by 4 does equal 12 on the left side, and since 12 equals 12, we know that 48 was the correct solution for x. And there you have 4 different examples of solving one-step equations with using the 4 different properties of equalities with the 4 different operations. If you found this video helpful, you can help support this channel by giving the video a thumbs up and letting me know in the comment section below. In some future videos, I'll go into solving some one-step equations that have negative numbers or integers, as well as rational numbers or fractions and decimals. As always, keep up the great work, and I'll see you in the next one.